Hi, everybody. Welcome to ES 2120 Dynamics for the school year of beginning in the fall of 2025. I'm recording this lecture on August 30th, 2025, and I've made some updates to our webpage. And I want to go over the syllabus with you, and I want to show you the updates and sort of give you a little bit more direction before you really get going on homework number one. So having said that, let's take a look at our Moodle page, and we'll start making some decisions and using this for content. The first thing I want to point out is at the top of our Moodle page, I've added this statement. Before you do your homework, watch the lectures. And I'm coding the lectures so that anything including the hashtag symbol is required before turning in your homework. The reason that it's required is because that's where the content of the course is. I know it's really tempting to just try to get started, and you've all had a really solid history in terms of your math and science background and education, but in this class, you need to learn new things every single time before you do homework. And those items and that structure are presented on those lectures that include a hashtag. So make sure that you watch them. And then that's where you'll get the information to do your homework. So as it says right here, for chapter 11, watch lectures 1 through 4. Lecture 1 is the lecture I'm recording right now. There was some other content there before, but I'm going to replace it with this. So lecture 1 is an introduction to the course. Lectures 2 through 4 are the course content for chapter 11. So as we go down, the first item that's really important is our syllabus. So once again, in terms of updating, I had not changed the tab correctly. This read syllabus for fall of 2024, where it is actually always has been the syllabus for fall 2025. But so let's take a look at that syllabus and just go through the items that will be required of you in order to be successful in this class. So the first thing is that, as you can see, we are online and asynchronous, which means we have no regular meetings of this course. Now, as far as I'm concerned, I'm always available to you. So anytime that you want to see me, please come see me. On Friday, which would have been August 29th, I had some of your classmates who wanted to work together, but I had not gotten any Calendly invites, so I didn't have the time allocated for them. And I feel really bad because I really would like to spend the time with the student. But the way to guarantee that you have that time with me is to go through Calendly to make that appointment. So please use this link in order to schedule, and it will automatically give you a Zoom link, but we don't have to meet by Zoom. If you schedule an appointment and then you want to meet face-to-face, just send me an email and say, I'd like to meet face-to-face, and that's what we'll do. All right. Anytime that we need to meet, this is the location that we can use. Unless you use Calendly, we can use the link that Calendly will automatically provide for us. So this course is vector mechanics, which is a huge field of study in engineering. And we are basically, as the name suggests, everything is a vector in this class. So it takes a little while to get used to. For example, when we refer to velocity, that is the magnitude of velocity is speed, but it's in a particular direction. So for example, if you have I'm going 100 miles an hour to Billings, which I don't know, maybe I wouldn't recommend that, but I'm just giving it as an example. That would be a vector because you have a magnitude of 100 miles an hour and you have a direction, which is to Billings. Of course, we would express that in X, Y, or radial components or something, but that is a vector. If you're just to say, I'm driving 100 miles an hour, that is not a vector, that's a scalar, and it's just speed. So that's sort of the distinction. So all the math we do in here is vector math. And the prerequisite for this class is that you are in or have completed Calc 2. And we also ask for Physics 1310. But if you're not in Physics 1310, if you're in statics, that will also do. So there's a couple different ways to get in the class. I do allow exceptions, but having Calc 1 completed is sort of the baseline for success, having the skills necessary to be successful in dynamics. We are using, just coming down here, all of these topics that we'll cover. We're going to talk about things moving. If you have had statics or Physics 1310, Newtonian physics, you'll know that when we have things moving at a changing velocity, whether the velocity is changing due to speed or direction or both, that you have a little bit more excitement going on the right-hand side of Newton's second law's equation. So that's sort of what we're dealing with in here, is things that are changing in terms of their acceleration, which once again, acceleration is a vector. So acceleration is the rate of change of velocity. So that can also represent either a change in magnitude or a change in direction, or both. The textbook that we're using is Vector Mechanics for Engineers Dynamics, 12th edition. Some of you have it as a combined book where it's Vector Mechanics for Engineers, Statics, and Dynamics. And you'll notice that whether you have it as a standalone book or as a combined book, that Dynamics begins at chapter 11. Chapters 1 through 10 are statics, although we only cover chapters 1 through 9 most of the time in the course itself, but the content for dynamics begins at chapter 11. Your grade in here is determined using this rubric. Your homework counts for 10%, your quizzes count for 10%, your midterm exam is worth 40% of your grade, and your final exam is worth 40% of your grade. The homework is done on your own. The quizzes are not proctored, but the midterm and the final are both proctored. And unless there's extenuating circumstances, for those of you who are on campus, I would like to proctor them myself. If you're off campus, we'll have a discussion and figure out how to make that happen and what qualifies as a suitable proctor. But generally, an overall percentage of 90 to 100 is an A, 80 to 90 is a B, and so forth, with 60 corresponding to an F. Now, the other part is I do not grade on a curve in any way. Sometimes I will award extra points, but in a course like this, if everybody gets an A, that is super with me. I don't have any problem with that whatsoever. Your grade will be based on your own work, not in comparison to your classmates. I also absolutely guarantee you an A with a 90% and guarantee you a B with an 80%. If you get a little bit lower than that, I reserve the right to round your grade up, but I'll never round your grade down. Okay, as it says here at the bottom of the syllabus, all of your homework must be scanned and submitted through Moodle. Don't accept handwritten submissions just because it's messy and I do not want to lose anything that you've given me. The other reason is it puts from my perspective, it puts all of your homework in the same place so I can grade it at the same time, which is very efficient for me because I just get it in my head, what I'm working on, grade this problem, move forward. Okay, so submit everything through Moodle. So that's the syllabus. There's also material on the syllabus that will help you with some other things, some universal syllabus requirements that are sort of like things that happen at the whole college. And I put a link on there with the syllabus because then everything is updated immediately. So we don't have to worry about changes that are not reflected in my syllabus because they will be reflected immediately. Okay, now going back to our Moodle page. Here's our class page, and the beginning part, the top section, is basically introductory information, and then we get into chapter 11. Okay, now right up here before we hit chapter 11, you'll notice that I have the first 5 weeks outlined. I've improved this schedule a little bit because I want to make sure I had it in a vaguer way where you have to do your homework 1 by here. And, I assumed that you would be watching the lectures before, but I want to make it real explicit. So in other words, lectures 1 through 4 go along with homework 1. So you need to finish those and then turn in your homework I've changed the date to September 5th. Then you need to watch lectures 5, 6, 7, 8, 9, and 9A, and then do homework number 2 And then finally, you'll start with 10 and 11, lectures number 10 and number 11, which actually are part of chapter 3. But in order to stay on schedule, you'll need to take those during the same week that you'll take quiz 1, which only covers chapters 11 and chapters 11 and 12. Okay, so if you stay on the schedule, watch the lectures, do the homeworks, do the quizzes, we'll be done with the first part, the first 1/4 of the class by September 17th, and then we'll move on to homeworks 3 and 4 and get ready for the midterm. All right, now where you look at each section, for example, chapter 11, kinematics of particles. First of all, it tells you watch these lectures 1 through 4, and the lecture that I'm doing today will be posted right here. There are some other items on here. I post the textbook right at first. I don't continue to post the textbook, but I post the textbook at first because sometimes students don't get their textbook on time, and I do not want you to be held up by not having a textbook. So if you need to refer to the textbook, here it is. If you have one of your own, this won't be relevant to you. But then watch lectures 2 and 3. Now the notes are not required. Those are for you. If there's anything extra that I think may be helpful to you or something that some of your classmates in past semesters have asked, I will post them here. So you may take a look, but how much time you spend with it is entirely driven by your learning. But it is required that you watch the lectures. Okay, so lectures, anything with a hashtag 1 through 4. That finishes off chapter 11. Then submit the homework, which, like I said, I've changed the due date to the 5th of September. So you have a little bit more time. Now, another thing, some people had trouble with problems 11.39. So I put some ideas for solving that problem right here. After you get done, after September 5th, and you're done with chapter 11, we're going to start with chapter 12. Once again, you watch the required lectures 5 through 9A. Should probably alert you to this. When I've recorded these lectures, sometimes when I go back and I watch them, I think I really like the content of chapter 9, but there's something about it that I left out or that I really want to emphasize. So when you see a lecture that has a hashtag, you still have to watch it because it's part of the course content, but an A just means it's an addendum, or sometimes there will be a B if I really needed to amend some things in a serious way. Once again, textbook, if you don't have your textbook with you, then we have dynamics lectures 5, 6, 7, 8, 9. Then we start on this primer on orbital mechanics, which is required reading for this course. I'll describe that in just a moment. Then 9A, and then submit homework for chapter 12. This says September 5th. It's going to be changed. It will be moved to September 12th, just like the schedule says up here. See right there, okay? And then when you get done with those 2 chapters, you'll be ready to start getting ready for the quiz. And here's the quiz, and here's where you submit your work for your quiz, which once again, it's not going to be September 12th, but that date will be September 17th. All right, so the way that you take a quiz is you click here and open up the material, but you don't submit your answers through the quiz feature. You do your work on engineering comp paper and you submit it here just the same way that you submit your homework. Once again, it is not a proctored item, so you don't have to worry about being proctored in any way. But you'll take it, it is timed, you have an hour, and then you need to submit it within an hour of opening up the quiz. Okay, now here's some more notes, some more problems that students have indicated in the past that they would like some help with. So I put notes for that. After we finish that section, we'll be done with 1/4 of the class, and then I'll open up chapter 13. We'll work through chapter 13 and 14, and that will take us to the midterm exam. All right, so I hope this helps, and I hope this clears a few things up. Once again, I'm always here available to you, but whether you can reach me if you have questions, I really recommend that you send me a Calendly invite, okay? Because that way I'll be sure to allocate time for you. And aside from that, I hope the extended deadlines for the first 2 homeworks and the quiz will help you get on your feet. And I hope this lecture clears everything up. So if you have any questions, please let me know. All of you have other classes with me. So that means you always have access to me within that class. So for example, if you are in physics lab with me, you can ask me questions there. If you have statics with me or engineering problem solving, you can ask questions of me there. But just work with me and I will work with you, and we will be hopefully universally successful in our efforts to get you successfully through dynamics. All right, everybody, have a wonderful day. Uh, and let me know what I can help you with. And I hope you have a great weekend, and we'll see you next week.